Students, this is lesson 432 again, part B. In this one, we're going to learn how to simplify radical expressions. Just as a quick reminder, remember how we simplified expressions when they had variables. And we can think of radicals as like variables. We're not going to change them. We're not going to, unless they're exactly the same, we're not going to combine them. So just as a reminder, the way we would simplify this is we would look for like terms, like those two, and then we would combine the 13r plus the 4r. And the reason we can do that is because they both have a factor of r. So what we really have using the distributive property is 13 plus 4 times r, which is 17r. So we're just combining the coefficients. That 13 plus 4 is 17r. And then this minus 12 here, minus 12t and 8t. Remember, that's like a negative 12t plus 8t. Negative 12 plus 8 is negative 4. So we could put negative 4t, or we could just write that as minus t, which is more simplified. And then we have minus 5, which is not a like term, so that just stays there that way. Okay. Here's an example of how you simplify radical expressions. Again, you look for like terms, and the way you know they're like terms is they have the same square root. So square root of 5 and the square root of 5 there. So what we're going to do is just combine the 4 and the 5 and make it 9 times the square root of 5. And both of these have the square root of 2 multiplying on them. So we're going to do 3 minus 2, which is 1 times the square root of 2. That's how we're going to simplify that. So this expression right here, since these are the same factor, both of them are multiplied by the square root of 3, using the distributive property, I could just do the square root of 3 times 14 minus 12 like that. And 14 minus 12 is 2. So I really have 2 times the square root of 3 for that one. All right. Sometimes you have to simplify the terms before you can combine them. So we were working on this yesterday. You notice right away that these aren't like terms. Like if it was the square root of 20 plus the square root of 20, you could combine those and say 2 times the square root of 20. These are both 1 times the square root of 20. But notice that we can simplify the square root of 20 because it has a perfect square factor of 4. And we can simplify the square root of 45 because it is a perfect square factor of 5. So the square root of 4 is 2. The square root of 9 is 3. And using the distributive property, now we have the square root of 5 multiplied by both of those. So we can just add the coefficients 2 plus 3, and we get 5 times the square root of 5. I'll do one more example like that. So these are both not simplified radicals. The square root of 18 has a perfect square factor of 9, so I'm going to write that out like this. And it's 9 times 2 equals 18. And square root of 8 has also got a perfect square factor, and that's 4. So I'm going to write that as the square root of 4 times the square root of 2. So 4 times 2 is 8. 9 times 2 is 18. And now I'm going to simplify that. Square root of 9, I'm going to just write that as 3 times the square root of 2. Square root of 4 is 2 times the square root of 2. And now I have the same, I have like radical terms, so I'm just going to combine the 3 plus 2 and make that 5 times the square root of 2. All right. So just doing a couple problems like this, we want to see if they're the same or not. And so we have square root of 2 plus square root of 2 plus square root of 2. Is that equal to the square root of 6? Using our idea that we just learned here, the way we can simplify this is by, these are all 1 times the square root of 2, right? So I can rewrite that as the square root of 2 plus the square root of 2 plus the square root of 2. Whoops, sorry about that. Using the distributive property, we have the square root of 2 multiplied in every one of those. So I can just write it as this. 1 plus 1 plus equals 1 times the square root of 2, which is 3 times the square root of 2. And that kind of makes sense anyway. You're adding the same thing 3 times. That's the same as 3 times that object. And it's just like this. If you did x plus x plus x like that, you would get 3x, right? Not x to the third or something like that. So they are not equivalent. So we're going to say no. And here's my justification. This is what it really equals, 3 times the square root of 2. All right. On number 16, you're going to look at that and just think, are those like terms? Can I just write that as 3 times the square root of 5? And if you're really not sure, you can check on your calculator. Also, this is another way to check it. If you do 3 times the square root of 2 plus the square root of 3, does that equal to 3 times the square root of 5? Let's check it. So 3 times the square root of 2. 3 times the square root of 2. I need to get out of that. Plus the square root of, what was the second part of that? Plus the square root of 3. That equals 5.97 about. And we remember what they did is they combined the 2 plus the 3. So we want to know if that's equal to 3 times the square root of 5. And it is not the same. So we're going to say no. And with that one, we checked with our calculator to see. So no. And I think my reason would be square root of 2 and square root of 3 are not like radical terms. Okay. All right. Go ahead and why don't you try 17 and 18, and we'll maybe do that one in class. I'm going to end the video here. If you want to practice a couple, see if you could do them. Do ones like 17 and 18, maybe 19, and we'll check that when we meet in class next time.